All right, now let's introduce software architecture. The term software architecture denotes the high-level structures of a system, right? The structural components of a system. It can be defined as a set of structures needed to reason about a software system, which comprise the software elements, the relations between them, and the properties of them. So you'll find that definition of an architecture actually applies to a lot of things, where you're talking about the elements, their properties, and the relationships between them. Now, if you prefer, the components, the properties of those components, and the relationships between them. Now, that's a very general description of an architecture of almost anything, and in software it still applies. You still have components, you have properties of those components, and you have the relationships between them. So it gets to be a question of, well, what is an architecture, and more importantly, what is not? When does program design become architecture? Well, probably when it gets big enough, you have to separate the components out. We deal with problem exploration or solution exploration. Okay, now this is fairly typical in almost every subject. The design deals with the problem space. Okay, so first we have to understand the problem and figure out what problem we're solving and say what will be a solution to that problem. Okay, so we can come up with a proposed solution. Now we have to design the solution. So design deals with the problem space, development deals with the solution space. Engineering, including software engineering, has been concerned with the solution space on the assumption that someone else has done the design. It starts with the assumption that someone knows what is to be built, developed, created, caused to be, and we can handle a certain amount of problem discovery, but not that much. And this is where we get into these arguments, or industry gets into the argument about the specifications moving around, and it's built a specification or it's not built a specification, or variations and all that sort of stuff that have plagued the software industry for 40 or 50 years, and is endemic. Now, this subject will not venture into design, but will teach architecture of the proposed solution. Right? Dealing with design is a different matter again, and starts getting into the space of innovation and creativity and design. In this subject, we're dealing with architecture, so we're going to assume that the problem itself is reasonably well understood and the required solution is reasonably well defined. And what we have to do is define an architecture that will satisfy the requirements of that solution. This subject will teach you good practices for software architecture. And it will teach you why it helps to understand the stakeholders and how to do this. It will teach how to develop the architecture gradually. Now, this is because it's really hard to do the whole thing at once. You really need to break it down into manageable parts and solve the problem in a manageable way. Otherwise, you're just dealing with far too many moving parts and far too many considerations. It will try to teach you to recognize the patterns of architectures and how to apply them. As I said before, now probably architecture patterns, although they are still relevant and people are still talking about them, most of you are probably going to be dealing much more with frameworks than anything else. Now, architecture determines qualities, so we try to get it right, or as right as we can. And by qualities, I mean, is it testable? Is it modifiable? Is it going to perform well? Is it reliable? Is it secure? If you don't get that right at the architecture stage, you're never going to get it right. You can't program it in afterwards. So we have to design it in the architecture. No one gets it perfect. So we need to know how to review an architecture and how to modify it and how to go around and how to critique it. All right? We just can't get it perfect. The problem is just far too hard. As I say, there's too many moving parts. We have to do something and then take a look at it. Now, a lot of people need to know things about the architecture, so we need to know how to tell them. That is, how can we document the architecture in a way that makes sense to them and has meaning to them, that they can understand and they can reason about it? Okay? We can't simply develop an architecture, say here it is, go run with it. We really have to collaborate with the stakeholders, simply because we're relying on them to guide us about the solution as much as we're building it. The topics that will be covered in this subject, we'll deal with stakeholders and all that. I know that almost every subject does talk about stakeholders, and this is no exception. We'll do that. So we're trying to understand the context of the problem, because an architecture, like any other software system, only makes sense in the context of its problem. We will deal with the architecture views, that is the conceptual architecture, the execution architecture, and the implementation architecture. Historically, there was also a development architecture, but personally I found that the implementation architecture and the development architecture were so close that there wasn't merit in distinguishing them. But there is merit in distinguishing the conceptual architecture, or the logical architecture, from the execution architecture, and distinguishing that from the implementation architecture. We'll deal with architecture patterns, and we'll deal with architecture qualities. We will deal with evaluating architectures, because that also is, so it requires a bit more than looking at it and saying, well, I don't like that. We'll deal with documenting architectures, because you have to be able to explain your architecture to other people, and they don't have your technical knowledge. So how do we present it to them? The subject will also deal with some specialization of architectures, or some special architectures, and that is the architectures for embedded systems, real-time control systems, embedded systems. Deal with web system architecture, product line architectures, and microservices architectures.